Hello and welcome back to Compiler Programming. In a video about a week ago, I tried to implement the separation between compilation, compile time stuff, and runtime scopes through flags. I ended up actually removing that system and went with the original option of having two scopes that are completely separated from each other, and that so far has been working out pretty good. I have also updated the way that compile time evaluation works. This is a very subtle change for now, and essentially what was happening before here is that we would create a new instance of a program every time we would get to compile time evaluation, and then we would kind of throw away that instance of the program, which is very wasteful because we have to copy a bunch of information, and that is not great. So now the idea is that we have sort of two instances of the program that are alive at the same time. One is for the target, that is what's going to be the runtime when the user actually runs the program, and another one is for the compile time evaluation. That is, you can see stored here on the new JIT struct. But if we are to reuse the same program, then there is a problem with the way that JITing is currently implemented. I actually added a test just before the videos to showcase, to trigger the error that I put in actually intentionally. Compile time execution. So here's the new test that checks for nested calls, which is also something that we actually haven't checked before. But now this is really a bit tricky to do. And I think there will be multiple things I will need to do eventually. So the first pass will be today, and the second one will involve some interesting stuff with how buffers are handled, but that is separately. Today, I'm just going to focus on this. So if I try to run the tests right now, it should panic and tell us what is the problem. It does. It says support reentend, or better yet, incremental JITting. What does that mean? So let's look at what happens right now when we try to JIT the program. First, we try to load the dynamic libraries that are referenced somewhere in the program. And this loop I actually already took care of first a while back and cleaned up a bit more, I think yesterday. Basically, now it is incremental in a sense that I can call it multiple times and nothing should break. We can actually verify that by just doing this, and we should still have just that panic, which I can actually disable to verify that everything else works. So let's disable this and run the tests again. Yeah, as you can see, it doesn't matter that we are doing this multiple times. Everything still works as it should. Okay, but that is actually not the case for the rest of the code. And there is a bunch of problems with how it's done at the moment. Okay, so there are the basic problem here is that these functions or this code, it is not expecting that it would be called multiple times. So for today, I just want to sort of go through it step by step and see if we are doing any mutating operations on the data that we need to take care of if we want to be able to call it multiple times with different, like as we add more things to the program, it should be possible to call it multiple times. Okay, so the first thing is here, and for now I think what we're going to do is, if there was already a compiled version of it, we're just gonna throw it away completely, so we will not make it incremental. We'll just try to make it reentrant. It means that, yeah, I can call it multiple times. So if JIT_buffer, I would say fixed buffer destroy of JIT buffer, and at the same time, I can do JIT buffer is 0. Okay, so that gets rid of the old code or old buffer stuff. Let's see what we need to do else. Okay, here we create a new buffer, we allocate global data, we copy that global data to where we want. Then we reset this. Everything so far seems pretty straightforward. This stuff is a bit awkward. So this is something I will need to think about to do cleanup somehow on reentry. So this is sort of debug or stack information, exception information for Windows to handle when the exception happens. And if we would like to have that we update it, then we either need to throw away the old one and get a new one, or something like that, because if we free the buffer, it is very possible. So we free the buffer here, but then we immediately create a new one, and it is very possible that we would actually get the same memory. Now you can cheat a bit and do this, and say heck deleting the old buffer after creating a new one to avoid actually no, that will only help for 2 calls, but if you have more calls, then we still will run into this problem. And yeah, so the problem is there is this RTL add function table where we say to the system what are the start, ends, and other information about the function. I think I have a video somewhere about what actually goes into here and where we implement part of this unwinding. But the point is we need to remove this somehow, and that means that we will need to retain this information somewhere. Okay, but we added to do. Let's go further. Okay. What else do we have? Code memory, trampoline target, make trampoline. This all is fine because all of it is operating on the result buffer. And here's the next interesting bit, which is about function code. I actually have no idea if it is possible to call it on the same function multiple times. So let's look at that here, function and code. Okay, what are you doing? First of all, if it's a macro, you're not doing anything. That is great. There is this small optimization I did that actually needs to be generalized to other stuff, but it shouldn't actually do anything. Yeah, that's fine. We can call it multiple times. checking the operand, checking the label. Code base RV. Yeah. So if it wasn't for this thing, then we would actually not need to update it. So maybe I would actually extract this part into another function, because the rest of it can't actually change. Yeah, so there is start and end RE, but they are well, I guess for now it can stay as is, but there is definitely a optimization opportunity here if nothing else. And also there is this normalize operands, which I think might be problematic for us. No, not really. So it just deals with the stack, and stack doesn't change. Let me think about this. So the question is if this function adjusts. Yeah, this is not really. This function is not reentrant. We cannot call it multiple times, and it will change the result actually. That will cause issues. So we do need to do something about that. I think the thing to do is to move this out of here and put it into function end. Yeah, this is where we are dealing with the stack anyway, so it makes sense that it goes here, but that means we need to change a couple of things in other places to make that work. First of all, we'll need to pass in the program star program, and secondly we need to have that loop that goes over instructions, right? Okay, now I also want to verify that I actually call function end in all the places where I should call it. So an extra thing that I will do is I will add a flag on function builder that will check if I'm actually doing it. So I'll say bool ended, I don't know, complete. I think I called it frozen at some point, so maybe it is time to revive that. And what will happen now is when we do function end, we will say builder frozen is true, and before everything else we will assert that is not frozen. And inside of function encode, we will assert maybe right here. Do I care about the freezing of macros? Well, let's try it like this. Now this stuff needs to move slightly. And you need to move as well. I'm so looking forward to not doing that when this language is ready. Okay, now everything seems fine. We just need to pass in a few more things. So context program and eval context program here. Okay, so that's actually all. We still have this test disabled, so if we did everything right, we should have everything still work, but yeah. So looks like that is not the case. We ended up with a function that was never frozen. Let's try to look at what that is and why that is the case. That is probably actually a macro, but let's see. Okay, so we have, oh, it's actually different. The problem is it is frozen, so we are here multiple times. Which function is this? Value. I don't have any information about this function. How do I figure this out? I guess I look at the value and I look at the descriptor. Yeah, I think I need more debug information about this because right now it's a bit hard to figure out where I actually am and what is this function. So we are in code. Yeah, that makes sense, but I still don't know. Value descriptor function. So it doesn't have any flags. Ah, yeah, I'm stupid. That is copy paste error in function encode. We actually expect it to be frozen. Let's try this again. Okay, now we are actually with the right error. We have a function that is not frozen. Okay, which test is that? That is in compile time eval. No, that isn't here. And there is still the big question which function it is. First, let's check if it's a macro function or not. It is a macro function, and I think that is okay. And this is sort of why I so I guess it is this function, and we are constructing that function ourselves. I think so. That's why it's not ended, because it doesn't have stack anyhow. Yeah, I think that's fine to check it here, because we don't really need to do any of these for a macro. Yeah, okay. Or not this, but adjustment of stack. Cool. Maybe that's worth a comment. Macro functions do not have own stack, and do not need freezing. Great. I think that actually deserves a commit by itself. So let's look at what we have. Yeah, we moved this stuff around. Asserting here, moving this stuff, and asserting here, and changing how we deal with function. And okay, so what I want to do is I want to add function source value, and I don't actually want to add runtime yet. That is this change. And what we will say is that move stack adjustment to function and instead of function encode. And let's explain why we are doing that. Function encode should not mutate instructions as it needs to be reentrant, or it's not exactly pure reentrant as it is used in reentrant JIT. Maybe reentrant is not the correct word. Used in, it's not really incremental either. I don't know what the right term is. Used in, let's call it incremental JIT, because eventually it will be incremental. Okay, so that takes care of that, and let's continue inspecting what we have inside of function encode. This encodes instruction, this changes, updates labels. So this is gonna be a bit awkward. We will mutate the labels, but that is sort of okay, I guess, because their position, I mean, technically their position won't even change, because like if we encode it, like say, let me explain. So originally we had function A that did something, right? And then we had function B that did something. And at this point, we jited our code and created machine code and resolved all the labels and whatever else is necessary. Then we decided to add a function, function C here. That will not change these two functions. They are already in the list of builders that we iterate over. So their order relative to each other should be exactly the same, and that means that they should stay similar, but it's not clear. So what I will do is I will say maybe we can check if label is already resolved and not, and stop here. Okay, to do. This just some encoding, more encoding. Out of curiosity, what will happen if I do this? Yeah, so first of all, this stuff is problematic. Okay, but that thing we can actually also move into function, and that is should be okay. I can also just remove it. It's honestly saving like one instruction right at the moment. So maybe that is good. I don't know. We can say to do generalize for all jumps to jumps. Okay, let's try to run the tests now again. Okay, so that is good. We removed another thing that was mutating. Uh-huh. So this stuff is so we have extra information about the function that is where it is located inside the virtual address space. Where are the pushes and pops for volatile registers, right? And so on. Again, this is necessary for Win3264 exception handling. And I'm just thinking if we actually want it here or we can move it around. I think we can. So let's try it out. That's gonna be a bit of a bigger change, but that's okay. We can make it happen. So if I go into here right now, actually it's here. So function layout right now is part of the function builder, but it needs not be. What we can do is we can take this out of here. We will probably also need to have some sort of mapping here and say function layout. Okay, lots of unhappy people, but let's think about this. Okay, so stack reservation size was inside of a layout. I think I will move it back to the other stuff. So we can do something like U64 stack. Actually, it's probably 32. Actually, it's S, whatever. Stack reserve, and that should help us fix this. Okay. Function builder. You no longer have a layout. This is now here. Great. the same stuff. Okay, and the idea would then be that the function encoding returns to us a new function layout instead of yeah, that's fine. Function layout result. Maybe we actually want to have it as an out parameter. Yes. I guess we do. Out layout. This just allows us to also indicate to the caller whether there is a valid layout or not. Okay. Maybe this check should be on outside though, because then we yeah, I will not do it right now, but I think this check should be on outside. Move to the colors, and this should be and turn into an assert. I think that's better. But regardless, then we can leave it as void, to be honest. And then out layout. And this is what we can do. And say out layout in array, like so. So here, and a bunch more replacement. Okay, that is neat, but we also want to actually zero it out and move in the stack reservation size, because right now it is stored on the builder. So stack reserve is builder's stack reserve, and the rest will be zeroed out. Function layout. Out value, no, it's not called out layout. Okay, that looks pretty decent. Now, of course, there is only an issue that we need to have that layout. Well, let's just say that you will get it from the outside, and it's somebody else's problem where to get it. Okay, looks good here. Obviously, we now have a bunch more problems, but we can deal with them. Okay. So this encodes all the functions, and this adds the exception unwinding data. And the reason it is a separate loop is because we put data after the functions instead of intermixed, because we don't want these data to be marked as executable memory. Probably it also deserves a comment, so let's add one. It is a separate loop from above. to make sure handling data is not in executable memory. But that poses a bit of a challenge for us, not much, but we would need to create actually an array here, a temporary one, where we would store function layout. Array function layout, layouts is dynamic array make of this, and we actually know the capacity of this array, which is function count. So we will create even the ones for macros. It is much easier to do it this way and much faster to do one allocation rather than sort of filtering here and do it incrementally. Okay, so function encode actually needs to change in here, where we would say that we do function layout out layout. Okay, getting back to our runtime. Now you complain, that's perfect. So we can say function layout star layout is dynamic array push layouts, and do I have like push uninitialized? Yeah, I actually do. So this is exactly what I want. Push uninitialized. And we can pass it here. So basically what this does is just it does not zero out memory, it does not accept the actual value that goes in there, just moves the pointer basically. It's very fast. But you need to know that whoever you're calling will be actually filling it in. Okay, now we encoded the functions, we store their layouts in here, and that means that we should be ready to do the following. So we had the builder, and we get a layout, and now we can pass in that layout into here. Okay, that seems perfect. I think this one is basically going to be exactly the same because this is inside P32. Yep, that is indeed the case. So the same jazz. We pass it in here. And I definitely don't want to unify these two functions because they're doing slightly different things, and making toggles for all those different things is not gonna be a fun thing. So instead, I'm just gonna copy paste these 4 lines of code, and that's gonna be okay. I don't have function count, but I have this. Okay, that was a chunky change, but I actually like it a lot. One thing I forgot to do in both cases is to say dynamic array destroy of layouts. And the same goes in here. Okay, let's see if that works. That is not very nice. So we are... Oh, I guess that actually comes from an initialized memory and yeah. So maybe I do want to push initialized here, even though it's a bit of a waste. It's technically not going to be necessary when we fix this stuff, but it's fine. At least I think that's the issue. And it is. Great. So that is pretty good. Let's actually do git add minus patch and look at what we need to say. Okay, and this I want to commit. This I also want to commit. Yes, 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 yes. Yes as well. The same thing here and here and here. That also goes. And this goes. And this goes. And this doesn't go. Can commit this, it's fine. It's also fine. It's also fine. Fine. Okay, and this one I actually do not want to commit. Yes. Yes. Okay, let's commit all of this stuff. And what we're going to say is do not store function layout on function builder. These structs are only required when we encode instructions and need to be updated anyway between JIT runs. So changed function in code to generate to return them. Okay, that is great. I think that now means that we can make this parameter const and just that will help us make sure that we are not doing funky stuff in function encode and that it is safe to more or less call it multiple times. That's the case. It gives me great confidence that we are not doing anything too bad here. I think like we are technically modifying the program because we are modifying these labels, but there is already this thing here, right? That will tell that that we need to think if we can not do that multiple times. But that seems pretty good. Let's get back to our runtime and continue looking at this stuff. So yeah, we still need to clean up these things, and we need to, this is fine, this is fine, this is now safe. I think this is also okay. What are you doing? You're not changing builder layout, you're only changing these two things. Okay, that seems pretty good. I think everything is fine here. Patch labels. Okay. And this just figures out permissions and protects the memory. And this one adds the function. Okay. So the only thing left really, I think, is to deal with this stuff. And so what I'm trying to do with the basic data structures is to keep them platform agnostic. So I don't want to just stick here something that is Windows specific. So I would just say void star platform info handle or something, and whichever platform wants to stick information into here, it can. And basically what I want to do then is I want to say that here I want to assert that we actually have that handle and say JIT platform maybe platform info. It's not really a handle. Let's just call it platform info or platform specific payload. That's good. That's what it's going to be called. Where are you? Okay. And we assert that that's the case, and we say runtime function star. Ook. We actually need to store a bit more than just runtime function. Okay, so let's then define this type. We say type def as struct win32 JIT info, and it will have runtime function star. How's it called? Function exception information. And I will also say u64 function exception info count. JIT info star. Okay, this is what we will do if JIT buffer else info is allocator allocate program, or actually we can just shove it into default allocator, I guess. And let's zero it out just to be safe. Actually, we can put in the info count, because that will be the same as the count of this stuff, and this just allocates a system array. So to be honest, we can also do that right away. We can say function exception info. I also misspelled it here. Let me fix that quickly. You need to have a type Great. Now you don't have a thing, but I can do info like so. Okay. Potentially an initialized local variable. Yes, that is fine. Because here we now just say info is this. And we need to destroy this stuff. We actually don't need to clean up these ones because they are part of the program itself. And we are cleaning up the runtime functions. Firefox, RTL. Well, let's go to function table. There's probably a remove function table or something. RTL, delete function table. Okay, great. That's what we want. It actually doesn't need this size, so maybe I was a bit too aggressive on that. Let's remove that. And we can just say RTL delete function table of info function exception info. Maybe I should call it function table, to be honest, since that seems to be what it's called in the original terminology. Function table, function table. Yeah, that seems more sane. Okay, so now we should take care of removing the function table. There should be actually a better way to do it. So I can say, did you use? I think it's something like, yeah, I think we should use this thing, install function table callback. But that's whole other can of worms, so I will not look at it right now. But basically what it allows you to do is instead of kind of creating this array and populating it with stuff and so on, you can just say whenever you come across a function in this chunk of memory, just call me and I will tell you what it is. And it might be a bit slower, but since we don't actually care about exceptions, like it should be faster to compile, but it might be slower at runtime if we come across an exception. But I don't expect us to come across exceptions. Like I'm not planning to use them in the way they used in C++. So I think that's a better trade-off, especially for compile time execution, where any exception is basically going to be like, no, you're not supposed to have it, and the whole compilation will crash. Okay. Yeah, well, let's try if it still works. It should, but you never know. It does work. So that is great. I guess it is time to try to run our example and see how terrible we are failing. So let's re-enable this test and see what is going on. Ta-da! And it's failed. So yeah. We are trying to call a function that is not frozen. That is very interesting. Okay, well, first of all, I want to add a bit of debug information. So function builder, I want to have slice source and function literal builder. I will, for now, I'll just shove body in there, maybe. Yeah, I guess what we'll do, you'll just say builder source is body source to do encompass the whole function, maybe. That should help us debug what actually is going on. Okay, we have a failed assertion. Obviously, it isn't function code, but now, yeah, that's not great. So that means that we have a function builder that is not coming from here, or did I not? Maybe I haven't rebuilt. Let's verify. No, so that means that we have other places where we do. Okay, where is function begin? Okay, makes sense. It's compile time eval. So we can do the same thing here where we source is source range. Actually here should be view source range, and do I have like source from source range? No. So source range file source range file source slice sub range, something like this. Does that work? What is in source points to a struct? Here. Source is not a member of source file. What's your name? File. You're called text. Okay. So now we should get a better sense. I guess. Yeah, we don't need this first token anymore. Does make sense? Okay. Let's take another look here. And great. Okay. So now we actually do see what we are trying to eval, and this is going to be get A. Okay. And we do call function and on this builder. So why are you not frozen? Uh-huh. I think I know why you're not frozen. And that is because we have another thing here. And this is flux ending body compilation, I think. So that essentially means that we have defined this function, but we never actually tried to call it. And if that's the case, then there is no reason to encode it because, I mean, we should, like, once we get to exports and imports, exported functions should be explicitly forced, I guess, at the end of the program. But that should still hold how it is right now. So let's see if that is more helpful or not. That is still not the issue. So let's look at the value and let's look at the descriptor function. So function flags are actually none. So that means that we should have done something to that function. Wait. It is this thing, right? But I'm very confused. I am calling function end here. So how is it that here we come across a function that is not? Okay, wait, where is the test? Let's be more precise about it. So it complains that this inline function that we created here has not been ended. That is very strange. Okay, let's try to do it this way. We do it like this. Okay. So we skip the first one and we go inside the second one. We check that builder is not frozen. We do stuff here. It does stuff to instructions. And which function are we actually looking at? To verify. To verify, we are looking at get B. Wasn't it get A before? Let me take a look at this. Oh, yeah. Okay. So I think this is actually a separate problem. all together. Um, huh. So right now, the issue is that we have parsed, so we are trying to execute this thing, and then the way it works right now is when you come across this colon colon, then whatever is to the right is constant expression, and you want to get rid of that terminology, but that's what it's called right now in the code. Essentially, this will be compile time executed. That's fine. In compile time execution, we would call get a, which calls get a, which we compile, and we trying to compile its body. That body is b. We try to resolve b. We come across this get b, and this is where things become tricky. We don't actually want to end up in a second compile time call. So what should happen is once we get into that mode, we need to stay there. So any resolution of extra things should be just a regular compilation and not something else, unless we go one level deeper and we like explicitly try to get into compile time execution of compile time execution, which doesn't make sense, to be honest. I might even explicitly deny that. But and the question is, how do I deal with this stuff? So right now, the way it decides whether it is a constant execution versus non-constant is a bit awkward at the moment. It is if maybe builder, yeah. So here's the actual logic for this decision here, and that is not what I want it to be. How do I want to handle this stuff? So I guess let's look at the program. So I guess it would be okay if these things just get flattened into a function. Essentially, if I do get a and it comes all the way around, and that does get b, oh, I mean, no, it should be recursive in that sense. But how do I deal with it? Let me look again. I will leave a marker here and then go again to the compile time execution. And let's look at again at what happens when we get in here. We get digit compilation, we make evaluation context. Okay, all of that seems perfectly fine. Scope, okay. I mean, it should actually be fine, but it isn't. Hmm. Okay, let me look at this error again. So our problem is builder isn't frozen. Okay. And this happens in the second compile time eval when we are trying to program cheat. So in the first compile time eval, we are stuck at this thing, token parse expression. Okay, that makes sense. So we are stuck on trying to parse this stuff, and this kicks off this whole shebang. Fine. But the question is why this nested one is so unhappy. And can I... Okay, let's do it again. So we're skipping the first test. Now we are in the right place. First, let's verify. No, it's actually a different value. This is a different builder, right? How are we creating a builder? We just call function begin. Okay, that all makes sense. And now let me check. Eval context builder frozen true. Okay, so this builder is frozen. But the other one isn't. And the other one isn't. Oh, I think I get it. I think I get it. Yeah. So what we can do here is we can say, let's do it like this. Descriptor function star function fake function. So what's going on is that we start function here and then we call function end over here. But because in here we actually recursively call to ourselves, we end up in a problem where when we try to encode that function, it is actually not ready yet. So this is what I will say. I had a right idea originally, but I just wasn't sure, like, we didn't actually have it in flags here. So descriptor function flags pending body compilation. That sounds like what we want. And I think we can... No, everything else is fine. Okay, let's see if that helps. Apparently it does not. I can messed up this stuff. Okay, I will sort it out later. What are you unhappy about? So the code that we just jitted seems to be not correct. Okay, actually, I will sort this out right now. Okay, call stack. Now we are in the outer parts of this. So if we look at locals and we look at eval context builder, okay, yeah, no. Now I added the flag, but I never actually cleared it. So it should be cleared here and not. Let's try it again. Okay, so the first test passes. Now the question is, will the second one pass? No, it won't. Okay. That is not great. Let's look at it again. Builder, builder value, descriptor function. So you don't have flags and you do not have that. Okay. That is annoying. Wait a second. Let's restart. Maybe I'm adding these flags to the wrong thing. If I look over here again, so get A does this, B, get B. And let's look at the stack trace more precisely. Parse content expression, scope entry force. So which entry are you trying to force? I assume you're trying to force B. Okay, that makes sense. Okay, you're trying to force B. Which scope are you actually trying to force it in? Scope, compile time JIT, compile time scope. So is it the same scope? Yeah, it is. Okay, so that is the right scope that you're trying to use. You're trying to force this lazy thing of B. And B. So which function are we choking on? Builder. We actually made progress because now we are now we cannot deal with B. So this function ends up being not frozen, which is kind of strange. Wait, we should not be even touching this function. it might be because we are clearing that flag in the wrong place there. Yep. Here is the problem. This should be... yikes. It's almost... I will need another flag. I will add a fix me here. Fix me. We should probably have a separate flag or a stack to track functions with compilation in progress to avoid loops. That would be a different test that I will also obviously need to do, but that is something different from what we are doing right now. Okay, let's try that again. That is not what I expected. We are exploding a check stack. Yeah, so yikes. So it might be that we will need to add this flag right now. How do I want to deal with this? I almost want to track referenced functions separately from the ones that we have. I'm not even sure how that would look like. Okay, so for now, what we will do is we will add that weird extra flag, and I will think about how to deal with it later on. Pending, yeah. Pending. 1, 2, 3, 4. Okay, so we are clearing this flag. We are adding the new flag in body compilation. And then we are clearing I could just check for frozen, but I think that would be bad. And then we need to clear it here. Okay, and now in here we can add another one that will check for in body compilation. That is getting a bit awkward, but let's get it working first, and then I can clean it up later. Try again. Okay, we are passing some other tests, so it's already great. We are passing the first compile time test, and and so far we are good. Let's see if that will actually work out. Okay. So somehow, okay, yeah. That is a very easy mistake to fix. I created this info, but I have not assigned it to treat platform specific payload is info. Okay. That is pretty straightforward. Ding, ding, ding. Okay. So now this function is very unhappy, and that's an interesting question. Why? Access violation reading location. That is not very. Oh, function table is 0. And that's not great. I mean, I'm allocating it here. Oh, actually we need to do it this way. Info function table, like so. It doesn't matter whether we had one before or not, we still need to create one. So you were completely right, the debugger. I was wrong. Ding, ding, ding. You're still very unhappy about this. Did I rebuild? I think I did. I mean, now I'm just unconditionally allocating it, so I'm not sure. Okay. What is going on? How are we ending up with the function table that is null? Okay, and now I want to break here. Still good. Function count is 0. Mm, yeah. Yeah, now that we are not actually compiling, so this is a new thing, but it's not sort of related to the change that we made. If we, it is very possible that we don't have any functions. So for now, I'll just say, I'll just do this. I'm not sure that this is the right thing to do. To do, consider if we want to not do JIT at all in this case. I don't know. I don't know what the right thing to do here is, but we can definitely guard against this particular issue. Okay. Builder source, body source. I assume that builder is null, but how? Oh yeah, if it is external, we don't have a builder. That is fine. I can fix it. Body source. That's actually correct. And it goes into here. And we are good. I think we finally got it. Let's rerun the tests in console just in case. And here we go. Well, that was quite a road. There were a couple of bumps, but I'm pretty happy with it. I'm not happy with the whole flag bonanza, but yeah, that is something for me to think about. But for now, that is basically it. We are now able to not only do multiple executions of the compile time, we can also make it recursive, like in this case, where one compile time execution kicks off another compile time, and there might be better ways to handle this kind of stuff, but for now, that is working great. So if you made it this far, then thank you very much for watching, and hopefully see you next time.